Chapter 11, Key Issue 3, Content Objective. Explain why industries cause pollution and face pollution challenges. The I-CAN statements. Describe the causes and effects of global warming and damage to the ozone layer. 2. Describe the causes and effects of regional and local air pollution and solid waste. 3. Compare and contrast point and non-point source of water pollution. Air pollution. At ground level, the Earth's average atmosphere is made up of about 78% nitrogen, 21% oxygen, and less than 1% argon. The remaining 0.04% includes several trace gases, some of which are critical. Air pollution is the concentration of trace substances at a greater level than occurs in natural air. These traces of gas can cause damage to property, can have adverse health effects to humans, and it can also affect other biosphere elements such as animals and plants. Burning fossil fuels discharges carbon dioxide. The GDP goes up. As GDP goes up, carbon emissions go up. We can see this with China and US as the largest emitters of carbon dioxide. CO2 levels in the atmosphere have risen by over 25% in the last 200 years. Most air pollution comes from factories and power plants, as well as motor vehicles. Factory plants let off sulfuric dioxides and solid particulates, and then motor vehicles let off carbon monoxide, hydrocarbons, and nitrogen oxides, as well as carbon emissions. When we look at the increase in global temperature, what we're talking, CO2s does correlate with global warming, which I'll talk about here in a second. And it says it causes the greenhouse effect. So again, when we look at basic climate change over the last 200 years, we've seen carbon dioxide being trapped, which creates greenhouse gas effect. So it's trapped in and not let out of our atmosphere, which increases the Earth's temperature. As a country's per capita GDP increases, per carbon dioxide emissions increase. It's shown for most countries, except for look at Europe. Their per capita is roughly between 30,000 to 50,000 per GDP per capita, and they show a decline in pollution, whereas countries like the United States and Southwest Asia show a high pollution level rates. So that is not true for all areas of the world. One exemption is Europe. Here we look at the temperature increase with the carbon dioxide emissions. We can see that average temperatures have risen by 2 degrees Fahrenheit since the 1880s. And this is directly linked to human actions, especially with burning fossil fuels in factories and vehicles, according to the International Team of UN Scientists. As I mentioned, global warming is when you have that trapping of the gas in the atmosphere and it melts polar ice sheets. It increases sea levels and it shifts precipitation, rain, and snow patterns. The ozone depletion. One large contributor to the ozone depletion is CFCs, which are chlorofluorocarbons. Our Earth's protective ozone layer is threatened by these pollutants. These pollutants are often found in refrigerator coolants or air conditioners. When they leak from the appliances, the CFCs are carried into the stratosphere or our atmosphere. Developed countries ceased using CFCs in air conditioners and refrigerators in 2020, whereas developing countries have made a pledge to end the use of CFCs by 2030. Look at regional pollution. Regional pollution, it affects regional vegetation and water. When we look at acid deposition, it's the accumulation of acids, including sulfuric acids and nitric acids on the Earth's surfaces, or on the Earth's surface rather. And it mainly manifests with, then what happens with the acid deposition, it will then combine with oxygen and water, and when it's dissolved in water, the acids will fall in precipitation, such as rain, snow, or fog. And the damage is linked to the killing of fish or fish kill-off in plants, depriving oxygen and nutrients, or oxygen to marine life in waterways, and also depriving nutrients such as nutrients depleted in the earth can harm worms and insects. And then buildings that are made of marble and limestone can corrode. We can see in this map, we look at the propensity of acid precipitation in the northeast region near industrial clusters. Then recently it's been shifted away because we know industry has shifted to the south and to Southern California. So acid deposition, acid precipitation off of all industrial manufacturing. When we look at the local scale of air pollution, we're looking at urban areas. Urban areas are the areas that are mostly polluted with large numbers or high arithmetic densities of factories, motor vehicles. The worst air pollution is in Asia, within the countries of China and India. What we see in terms of air pollution in these urban areas, it's hydrocarbons. So it's sunlight, and these hydrocarbons will then form photochemical smog, which harms respiratory systems of humans. And then we also have particulates, which is a combination of dust and smoke particles that follow the exhaust of factory production outside the stacks, smokestacks. And again, worst urban air pollution occurs when winds are slight, skies are clear, and temperature inversions exist. When we talk about, when you look at temperature inversions, in which air is warmer at higher temperatures and air is cooler at lower temperatures, that's a temperature inversion. Here's a look at Mexico City with the photochemical smog on a local level in an urban area. And mixed into that, we could probably most likely see particulates, which again would be that smokestack dust from industries. All right, let's move on to solid waste. Solid waste, on average, solid waste a human generates on average 4 pounds of trash in the U.S. 60% comes from resident houses and 40% comes from businesses. The United States disposes of most of the solid waste. More than 1/2 of the country's waste is trucked to landfills and buried under soil. So again, half goes to sanitary landfills. Paper products account for the largest percentage of solid waste in the U.S. These paper products are like corrugated cardboard, and then other papers that are like colored or multi-layered paper that doesn't recycle, are pollutants. And then what we've seen with the concentration of landfills in the U.S., we saw some elimination of solid waste pollution, but they may only hide it with burying in these sanitation landfills temporarily, because chemicals released by the decomposing solid waste can leak into landfills into the groundwater. This can contaminate water wells, soil, and nearby streams. The number of landfills in the United States declined about 3/4 since the 1990s, because small rural town landfills have now been merged into larger regional landfills. In some states with large populations, especially along the 5th largest cluster, the Northeast, northeastern United States, such as New Jersey and New York, they ship their waste to Pennsylvania, to a town called Johnstown, Pennsylvania. All right, let's talk about pollution. You have point source pollution and non-point source pollution. When we look at point source pollution, these are usually smaller. They're much easier to control, so you can pinpoint the specific location. And oftentimes these are manufacturers of industrial manufacturing that may dump into a river or a waterway, or municipal sewage systems, which are common of suburbs in urban areas. Non-point source pollution is much larger and more difficult to control. The largest polluter of non-point source pollution is agriculture, with the use of pesticides, herbicides, fertilizers that they spray on the fields, and they create that eutrophication, which is the blending within rivers or lakes. It is important to understand developed regions of the world have municipal sewage systems, or in developing regions they don't have municipal sewage systems. So oftentimes in developing countries with that point source pollution, it'll be more difficult to contain because the residents' drains and untreated waste goes into rivers and lakes, and that eventually mixes with the drinking water and can create waterborne illnesses such as cholera or typhoid or dysentery, and they're major causes of death in those countries that are stage 2 or stage 3 along the epidemiological model. All right, take a moment to review what you've learned. All right, and that'll be the end of the notes.